Hi guys, good afternoon. So in the last session, we went up with the DHCP relay agent concept, right? And we went with the basics of routing, correct? Now, there was a task for you about DHCP relay agent. How many of you were successfully able to complete the task? Okay, good. Everybody, right? Right, but failed. Okay. What was the issue? Like which network? Mm-hmm. For DHCP server, so you could assign here, right? You could assign here like 192, 160, what's the network? 50.100 or 50.10, whatever. Now, okay. Then who else faced the problem? Solved. What was the issue? Our router receiving request message, but it is not assigning IP address to the. Which one? Hard. This one. So it received the DHCP discover message request. Like how did you resolve the issue? Actually, I don't know how it is resolved. Yesterday it was not. Overnight magic, huh? Yesterday it was not working, today it's working. That's great. Okay. Then next person. Done. Everybody else? Done. Why? Huh? Done. Yes. Not done. Not tried or failed? Not tried. Online people? After lunch. Silence. Okay. Hmm. Maybe you forgot to do right. Hmm. So the command was successful or failed? Successful. Overnight magic. Okay. See, what is the configuration here? A simple configuration is, let's say for R1. Okay. Consider the interfaces. Let's say this is Z0 by 0. This one has Z0 by 1. And this one has Z0 by 2. Okay. Same. Z0 by 1. Z0 by 0. Z0 by 2. This is Z0 by 0. Z0 by 1. Okay. So in this case, on the first of all, here you will configure 3 pools, right? If we talk about pool number 1, pool 1 network will be 10.110/24, right? Gateway you will configure here, which is 10.111. And DNS, it's not mandatory. but still you can configure. Okay, this is the pool number one. Pool number two, this will be 11, 1111. 2 will be the gateway, and this is pool number three, which will be 12, 12, 11, 3. These are the three pools you will configure. Okay, then on the DHCP server, the IP you will configure. So let's say this is the IP you will configure. Okay. Now relay agent you have to configure R1 also, R2 also, and R3 also. All the three routers you have to configure as relay agent, right? So how you will configure? On R1 you are going to configure. You're going to say interface x0/0. Then you will say IP helper address. And what will be the IP address here? Server IP 50.100. Okay. How you will configure on the R2? Then same. Correct. This will be same. What about R3? Also same. Because server IP is same, interface is same, so command is also same. But still, what will happen? You will see that these guys will get the IP address. These people and these people, they will not get the IP address. Why? On DHCP server, you have given routes. Okay, here you have routes. Okay, three routes you will configure. 1, 2, and 3. Not like this. So on the DHCP server, you will configure three routes. One for 10 network, another one for 11 network, and third one for 12 network. These three routes you will configure on the DHCP server, or else simply you can give one default route towards this side. One single default route towards R1. So here there is no issues. But still these guys will not get the IP address. Why? Because R1 doesn't have a route for 11 and 12. Right? So you'll give on R1, you'll give a route for 11 as well as 12. Now what will happen? These guys will start getting the IP address, but again, this guy will not get the IP address. Why? Because R2 doesn't have a route. So on R2, you'll configure a route for 12 network. So that means you have to configure complete routing also in this case. You need to configure full routing also. If routing is not proper, in that case, you will face problems. If there is no proper routing, in that case, you are going to face problems here. Understood? Right? Now you can practice. Right? Those who fail will try again. Okay. Now, one more task I'm giving you for this. This is a question you guys mostly ask me. So today I'll ask you. You have a router. This is your gateway. Switch. PC1. PC2. Interfaces you can take any. For example, let's say Z0 by 1, 0. VLAN 10, VLAN 20. This PC should get a IP address from the network, let's say 10.1.1.0/24. PC1 should get an IP address from this network, and PC2 should get an IP address from 11.1.1.0/20. This is the task. Simple. Up to you. This is your DHCP server. Okay, what is the task? PC1 should receive an IP address from the subnet 10.1.1.0/20. Okay. PC2 should receive an IP address from the subnet 11.1.1.0/20. Easy, right? Yes or no? It's easy for everyone. Hmm? Okay. Online people, take a screenshot and drop it in the group. Make sure you complete this task. You have weekend to yourself, right? Done. There are online people today. Okay. Task is clear. Hmm. Hmm? Yes, PCs will communicate with each other. You will give it out. You want communication, right? The question is for DHCP relay agent only. Now, if you want that, okay, they should communicate with each other, then you configure complete routing. They'll start communicating. Not necessary. Because why not necessary? The task is for DHCP relay agent. Right now, the task is not for routing. Okay. All right. This task is clear. Okay, then complete this task. Now, today we'll start with the static routing. Now, as of now, we know that routing is of how many types? Two types. Routing is of two types. One is another one is dynamic. So in static routing, what happens? That we have to manually define the routes. The admin has to manually define routes to all the destination networks, right? So here we can say in this case, routes are manually added to the routing table. Here the routes are manually added. Correct? While here, what happens? The routes are dynamically with the help of routing protocols. Okay. This is clear. Okay. Now, static routing. In static routing, we have different types. What are the different types? So we have number one, recursive static route. Then we have directly connected static route. Okay. I'll simply say directly connected. Number three, fully specified. Then loading static. Then host route. Then network based null route. Then default. These are the different types we are going to study. Okay. And if we talk about dynamic routing, your dynamic routing is further divided into three categories. Yes. Right? Huh? Only two. Only two. Which is IGP and EG. Okay. Interior gateway. Protocol. And EGP, which is exterior gateway protocol. Exterior gateway protocol. Okay. Interior and exterior. Now, what is IGP and what is EGP? IGP provides communication within an autonomous system, and EGP provides communication between different autonomous systems. Okay. So we can simply say that this is responsible for same AS communication, while this is responsible for different AS communication. Correct. Then your IGP is further divided into three categories. Correct. Number one, distance vector. Number two, link state. Number three, hybrid. Correct. Now distance vector based on. So what other protocols does? What do you mean by distance vector? What do you mean by distance vector? Hmm? Distance means distance. Vector means direction. So they only focus on the distance and the direction. That's it. That in which direction? How far? How far? In which direction? They don't focus on the characteristics that whether it is a single way, two way, or a highway, or just a broken road. That means they doesn't care about quality. They care about distance only. Right? Okay. So distance vector protocols. Okay. So you say they only focus on distance between source and destination. That's it. They don't check anything else. They only focus on distance. While link state, they focus on the bandwidth. Focus on bandwidth. Then hybrid. This is, you can say, has features of both distance vector and links. They are kind of a combination of both. Okay. So under distance vector, we have protocols. Then IGR. IGR. Here we have protocols. OSPF. RSS. And here we have only one protocol. If we talk about your exterior gateway protocol, only one category, which is path vector. So they do not focus on metric concept. They have attributes. Okay. And only one protocol we have, which is about DG. Clear? Now, if we talk about static route, you know, static route we manually define it. We manually define it. So that means we have two routers, for example. Now, my question here: how your router populates the routing table? Before I explain anything else, tell me how router populates the routing table. Tell me. How router populates the routing key. Tell me. Should we calculate like connected routers? Directly connected. Hmm? Should we check the directly connected route? And how it will check the directly connected routes? Ethernet. Ethernet. Through Ethernet. IP address on the interface. Whenever you configure an IP on an interface, from there itself, router starts adding the routes. Okay. See here. Okay. Let's start these notes. R1. Both R1 and R2 are there. Allow them to come up. A lot of time. Okay, take a look. If I say show IP route, any route right now? Why? There is no IP address configured on the router. Okay. Show IP interface brief. So I can see here unassigned. Okay. If I configure the IP interface gig 0/0, and let's say I'll configure IP 12.1. 12.1, 255, 255. So to show IP route, do you think route has been added? Yes. No. Hmm? But I have assigned the IP, right? I have assigned the IP. Hmm? No? Wait. We are talking about IP address assignment, okay? Do show IP interface brief. You can see IP is there. Is it? Hmm? Interface is down. The interface is down. So what is the problem? If interface is down, what is the issue? Who cannot communicate? R1, R2. Hmm? Okay. If I take it down, interface will be up, right? If interface is up, route has been added. Correct? So can you say that, okay, when you assign IP address, routing added? Hmm? Then what can you say? Now explain me this. Interface is in up state. Interface is in up state. Hmm? Okay, fine. Yes. Now my interface is in active state, right? And I have the route in my routing table. So what actually happens in the backend when you assign an IP address? Let's say if I say default interface gig 0/0, my IP address has been removed, right? My IP address has been removed. And I'll say debug IP routing. Let's take a look what happens when I assign an IP address. IP address 192.168.12.1 255.255.255. What happened? Interface. Now, if my interface is active and I assign an IP address, what happens? Route is added. Route is added to the routing table. So this is the network I configured 192.168.12.0 via 0.0.0.0. That means directly connect. Okay, and this is a connected route, and metric is AD value 1, metric is 1. Okay, so the interface gigabit Ethernet 0/0. This is what? This is my exit interface. This is my exit interface. That if I need to communicate with this network, I can exit the traffic via this interface. This has been added to the routing table. Clear? Okay. Then it also show that okay, this has been variably subnetted. That means you have used the IP also. You have used the IP also on the router from this subnet. So if I want to reach that particular IP address, then also I need to have a information in my routing table. That means basically what is happening here for 12.0 network, I say that okay, I can go via this path. I can use this interface to forward the traffic. But if I want to communicate with this IP only, I don't need to forward traffic outside of this interface. I need to communicate with this interface itself. Okay. And that's why one specific route has been added for this, the local route, which defines that, okay, this network or this particular IP address is locally present. So see here, add 12.1/32 via this connected matrix this. Is that clear? Yes or no? Okay. Now the network has been added. But as soon as I shut down my interface, what happens? See, delete the subnet route to this and delete the subnet route to this. Now here you should make a note that if a directly connected route or if a local route has to be added to the routing table, the interface has to be in the active state or up state. The interface has to be up, right? So mention it here. Mention it like this. A directly connected or local route will be added to the routing table only if the interface connected to that network is in up state, or you can say is simply up. If the interface is up, then only the local and directly connected route will be added to the routing table. Otherwise, it will not be added to the routing table. Clear? Yes or no? Yes. Okay. Now here, there's one more way I can check. Okay. Let's say if I go and say no shutdown. So it will add all those things again in the routing table. My router will add it. Now if I check to show IP route. Now these are directly connected routes. How do I check that, okay, what is their administrative distance and all? Hmm? Interface with hmm? How? Show me, tell me the comment. Yes, one more. Not able to see the screen, guys. Everybody not able to see the screen or online people?
Yeah, we're able to see the screen.
Oh. Okay. Yes, somebody was telling me a comment. Huh? Show something. Show IP interface build. Where is the matrix? Hmm? Where's the metric? Hmm? So running config. So I should check for what? Route or interface. That's it. Okay, I'll show you entire running configuration. No problem. Let me know if you see something. Hmm? Any other comment? Don't show IP route. Divine. Okay, good. Those show IP protocols. So no protocol is running. Static is not a protocol. Hmm? And right now this is directly connected, not definitely a protocol. Then do show interface. Do show interface name Z0 by 0. That's it. Hmm? See, to show IP routes. What do we have? We have the routes. Now you can say these are already attached. Okay, these are already attached. So, slash value it will not take 12.1. Now you see known via connected. What is the administrative distance? What is the metric? So you just type in the route. That's it. You just give the route. Clear? Note it down. You check the administrative distance and metric of the route. Or see, normally it will already be present. Okay, in the route, it will already show. So you can say of a connected route, it can use the following command. Everywhere. But for most of the protocols, it will show you in the routing table itself. Show IP route, and here whatever the route you have, okay, that route you will type. In most cases, the ADN method is displayed within the routing table one. Okay. How it is displayed? There will be this kind of bracket. First of all, there will be AD, and then after there will be method. Clear? Now here we have a problem. Notice you see here, if I shut down my interface, what happens? My routes get deleted. And how many log entries are there? So many, right? And if I say no shutdown, what is happening? Routes are being added. Again, if I say shutdown, what is happening? Hmm? Again, if I say no shutdown, what is happening? Added. Now, right now, I have only one directly connected route. But in real scenarios, I'm going to have only one route that is also directly connected. Is it going to happen? No. I'll have multiple route entries. I'll have multiple route entries. So that means if I have 10 networks, if I have 10 networks configured on my router, maybe I'm using loopback interfaces and all. So I may have 10 networks. Then maybe I have 10 or 15 static routes configured. Correct? So if my interface will go down, what will happen? Hmm? The routes will be deleted. If my interface will come up, routes will be added. Again, my interface goes down, deleted. Again, my interface comes up, and this adding and deleting of routes will consume CPU, will consume CPU. Now imagine a condition where my link is flapping, might be a cable mistake also. My link is going up and down, up and down, up and down. What will happen? My routes will keep on adding, deleting, adding, deleting, adding, and right. Now, if my link is flapping, my routes are adding and deleting, and number of logs will be generated. That will consume a heavy CPU. CPU uses will be high. Now what will problem I explained? You tell me the solution. What is the solution? Mhm. This is the command. Saved configuration. You can see successfully saved. Okay. Still what's happening? Hmm? This is startup only. See here. Do show start. Startup config. This is saved in startup config only. But still the problem exists. Routes are getting deleted and routes are getting added. What to do? Because if such kind of situation is there, CPU usage will be high, router will not be able to power the traffic. Then whose job is in danger? Network engineer. And who is the network engineer? We. Then what to do? Something regarding log. Something regarding log. Syslog. So what to do with this syslog? Syslog will stop generating logs. Let's say I'll stop debugging. I'll stop logging, but still my routes will get added and deleted. You can take a look, right? Do show IP route. Routes are there. Shut down the interface. No routes. No shut down the interface. Nothing is going to happen. It's not like if we close the eyes, nobody can see us. Hmm? The thing is still going to be there. What to do? Hmm? Stick or Fevicol so that routes will not go here and there. Right? Same thing we can do. Same thing we can do here. Whenever you add a route, this is connected route, this will definitely go out and come back because this is something we cannot do anything about. But if you have configured a static route, let's say here. So let's configure first of all the IP addresses and everything. Then I'll show you. Okay, about connected routes, we cannot do anything. Interface git 0/0 IP address 168. So I have a Z0/0 interface where I have 12.2 IP, and then I have two loopbacks. So interface loopback 1 IP address. These are the addresses, I believe. 10.1.1.1 loopback 2 20 loopback 3 Everybody remembers this coming here. Loopback 4 40 loopback 5 this is okay. So right now if I check the show IP route, I have all the networks in my cloud. This is R1. What is the host name here? This is R2. IP address. Okay. So now what I'll do is I'll remove the route and then I'll configure a static or default route, let's say. IP route. What will be my next route? 12.2, correct? Now check. Do show IP route. The thing is now if I go and shut down the interface, it will remove the routes, right? So if I say do show IP route static, correct? I have the route. Interface gig 0/0 shut down. The route will be removed, right? If I check, I don't have the route, correct? And if I say no shutdown, I have the route. Correct. So I want that, okay, even though my network is flapping, even though my link is flapping, my interface is flapping, my route should not be removed from the routing table. So how can I do that? For this thing, what we can do is we can say IP route, or let's say for this network, I'll create 10.1.1.0.255.255.0.1. This is normally how we configure a route. What I can do, I can make it permanent. I can make it permanent. Now check. Do show IP route. Okay. Or I will say do show IP route static, so that it will not create a confusion. So you can see I have a static route and I have a default route. Now this is a permanent route, right? This is a permanent route and this is a non-permanent route. We didn't use a permanent keyword here. If I use the shutdown keyword, interface 0 shutdown. So what will happen? See, first of all, line console 0 login secrets. Now let's take it. It will show IP routes. Did it get removed? No. If I say no shutdown, no shutdown. So my default route will come in because default route is not permanent right now. So check. But my permanent route is not going out right now. If I shut down the interface also, okay, you will see that my permanent route is still there. This is clear. So now what will happen? Even the link flaps will not affect the routing table. My routes will remain in the routing table, even if the links are flapping. Clear? Right? Okay. Communication won't be there. But at least I can save some CPU so that my router can process the things. Right? Yeah. Okay. See here, you show run pipe section IP route. Okay. Hmm. Now your default route will also not get affected. See. No shutdown. Interface leave 0/0. No shutdown. Once the interface is up, you will see that even your default route now it will not get affected. Right now interface is up. Let's shut down the interface. If they shut down the interface, still doesn't get affected. Because default is also what? A type of static route only. Correct? Yes. Yes, Mohammed Hussain, right? Abdul. Then Mohammed Hussain is also there, right? Hmm? Okay. So this is clear?
Sir, this permanently for both the static and the default, right?
Yes. This time permanent keyword is used for both static and default.
So here for 10.1.1.1, two routes are there. One is static and one is default. So while pinging from this router to the 10.1, which route will prefer?
Now this question's answer you guys tell. That right now I have a route which is default route, and another route I have 10.110/24, right? So if I ping 10.1.1.1, if I ping 10.1.1.1, which route will be preferred, static or default, and why? Static was a prefix, right? Whenever router looks at the routing table, whenever router looks at the routing table, router always checks for the longest prefix match. Router always checks for the longest prefix match. Okay. So if we take a look, we have two routes right now. Okay. When router looks at the routing table, router looks for the longest prefix match. Okay. Router will try to find out for longest prefix match. Now here I have two routes which can forward the traffic to 10.1.1.1. So if I take a look at the default route, okay, what is my prefix length here? If you take a look at this, what is my prefix length here? 0. My prefix length here is 0. While if I look at the second route, what is my prefix length? Which is the longest? 24 or 0? 24. Or in simple language, if you want to understand, always understand router will always prefer more specific route. Okay. More specific. Now, out of these two for 10.1.1.1, which is the more specific route? /24. Is that clear? So in this case, router will prefer which route? Static route. And one more point here. Make a note of it. According to the longest prefix match rule, the default route is the least preferable route. Or least preferred route. That means if the router doesn't have any option left, in that case, router will go with the default route. Otherwise, router will always try to find out a more specific route. But if router doesn't find anything else, then router will go with the default route. Is that clear? Online people clear?
Oh, yes, sir. Thank you.
Okay. Hmm? Hmm. Mhm. Clapping means interface goes down. So if interface goes down, what will happen? Log will be there. Interface is coming up, log will be there. So that is for the route, right? Log will still be there. For the interface, that okay, interface is going down, interface is going up, going down, going up. Logs will be there. And in other cases, the admin doesn't have to always go and check the router only. Communication is also like it's not about communication only. In organizations, we are using different monitoring tools. We go with the SNMP, we go with the syslog. These kind of tools are being used. Other network monitoring tools are used. Other network monitoring tools are also used. So what happens? These tools, as soon as there is anything wrong in the network, they will leave a warning for the admin. No need to go to the router also. No need to go to the router also. Wherever the admin is, admin will get a message or email and they will get to know that, okay, there is something wrong with the network. Yeah, I discussed that, okay, I will discuss SNMP, right? You studied SNMP. What is the use of it? What is the use of SNMP? In SNMP, you have SNMP server, SNMP agent. What is an agent? No. Slog is different. What is
Uh,
Yes.
SNMP is used for network devices monitoring purpose, I think.
Correct. But in SNMP, you have SNMP server and or manager, SNMP manager and agent. So agent is what? It's a program that is available on all your network devices, your routers, firewalls, switches, cameras, XYZ devices. Correct. Then you have a manager. Now, what is the manager? Hmm? What is a manager? Have you seen SNMP manager? No. What did you study about SNMP manager? Approved. What did you study? SNMP manager. Hmm? Forgot. Manager. Everybody forgot. Okay. Ask the agent, but what it is? Every manager asks their employees to submit the information, not just SNMP manager. All the managers does that. But what is SNMP manager? It's just a program only. Want to see? This is an SNMP manager. Okay. So you see, I can see here all the warnings that, okay, there are 11 things which are down. There are 2 warnings, 16 are there which are good. Right? If I take a look at all my devices in the network. So right now this is a PC and in this I have this network manager installed. So it is checking, right? My device health. It is checking. It is checking that whether or not I have internet connectivity. It is testing connectivity automatically with my gateway. Okay. It is testing connectivity with my DNS server. Then any other clients I haven't added. Okay. Then after If you see, I have also added here an SNMP agent. This is basically a router only. This is basically a router only. So I can manage and I can check, right, what is the CPU load, what is the status of the interfaces. If you see red, that means these are completely down. Now I don't need to go and check the log also. It is already telling me here that, okay, something is down. Right? Clear? So in a network, at a time, not only one protocol is being used, there are hundreds of protocols running together. Clear? Any doubts? If you want to see the functioning of SNMP and also tomorrow I will show you this. Because right now our topology is already running, so we'll have to shut down this topology to add the router again. Okay. So this thing tell me tomorrow on Monday. Tomorrow we don't have a session. Monday. So Monday you tell me. So first of all we'll discuss SNMP and then we will go with the further circuits. Okay. So any other doubts? No. Have you seen OIDs? That also Monday only. Monday we'll see. Okay, one more thing. Okay, that part I'll discuss. So today let's discuss about the recursive static route. Okay, first type. Right now, the route we discussed is what? It's a recursive static route only. Now, what is a recursive static route? Recursive static route will check for the gateway and again we can check for reaching the gateway. So in static routing, number one, recursive static route. This is the first type. Okay. So how do you configure it? First of all, you use the command IP route. Then you say network ID, subnet mask, then you use next of address. Okay, this is your recursive static route. Okay, so that means if I'm manually adding a route, it should be added to the routing table. Let's say if I add a route, IP route, let's say I want to add 20.1.1.0.255.255.2550. Can I add this route? Yes. Will my router accept it? Is my router going to accept this route? Yes or no?
No.
Take a look at our topology. See? Right? Now tell me, will my router accept this route or it will give me an error? Accept. Accept it. Can I see this route in my routing table? Yes, no, yes, no. How many are saying yes? 1, 2, 3. What about the rest of them? Huh? Afterwards. Anybody saying no? Why? Next stop is good. A route will not be added to the routing table until or unless your next stop is reached. That is the same reason that when the interface was down, this is the same reason that when your interface was down, your route was not there in the routing table. Because there is no reachability. So before adding a route in the routing table, router will always check for the reachability, that whether or not the next stop is reachable or not. Okay. So if you check in the routing table, are there? Why? Because my next stop is not reachable. But it is present in my running bucket. It is present in my running config. Clear? In my running config, the route is going to be there, but it will not be present in my routing table. Why? Next stop is not reachable. Clear? Until or unless your next stop is reachable, router will not install it. You can see what is happening at the back end. Okay, see here. Okay. Now let's try to add it again. Any log? No. Reachability itself is not there. But in the same place, okay, if I had given it something like 12.2, now this is the next stop which is reachable. See here. It will be added to my. So before performing anything, my router will check that whether or not the next stop is reachable or not. Yeah. Understood this thing? Note it down. Before adding a route in the routing table, router will always check for next stop reachability. For anything. Okay. If next stop is reachable, the route will be added to the routing table. If the next stop is not reachable, the route will be present in the running config, but it will not be added to the routing table. Yeah. Got it? Now I'll ask you one last question for the day. Okay. Let's say from R1, I try to ping 10.1.1.1. Okay. Hear it carefully. From R1, I'm trying to ping 10.1.1.1. Right? First question. Let me show you the routing table also. This is my routing table as of now. Will I be able to ping? Will I be able to ping? Everybody agrees? Let's test the communication also. I'm able to ping. Totally fine. Okay. Hmm? Yeah, to check the reachability. We are reachable. We are able to reach. Correct? This was not the question. Question is, what will be the source IP? In this message, what will be the source IP? Tell me the IP. 192.168.12.1. This was also not the question. Question is why? Question is why? Let's say, wait a minute. What I'll do is interface loopback 1, IP address, let's say 1.1.1.1. 255.255.255. You don't show IP interface 3. You can take a look. I have more than one IP. You do show IP route. This is my routing table. And I have the communication. So what is the source IP and why? That's what because router doesn't care about the network, it will care about the next one. Router doesn't care about the network. Okay. It will only check the next one. So my next stop is 12.2. But via 12.1 is the source. Packet will be passing through 12.1. Why? Because interface. When
Router always consider exit interface IP.
Exactly. Okay. Router will always use exit interface IP as the source IP. Router will always use exit interface IP as the source IP. Okay. So you can mention this thing. Whenever router forwards a packet for a different network, will use the exit interface IP as the source IP address in the clear. Now what if I want the loopback to be the source? I don't want 12.1 as the source IP. I want 1.1.1.1 as the source IP. Do ping connects. Okay. Let me capture the packets. Okay. And I'll capture ICMP only. First of all, let's say if I say ping 10.1.1.1, Here you can take a look at the source IP, which is 12.1. Agree? Now I don't want to use 12.1. I want to use 1.1.1.1 as the source IP. We completed routing in CCNA in like 2-3 days. 1 day static, second day dynamic, third day OSPF complete. Right? Now, if we are spending a month over it, that means we have to dig deeper and deeper. Correct? So tell me. I have to configure loopback. Okay, how will I do that? Okay. So first of all, I need to remove the route right, which is already present. Okay. Do so. So let's say which route I need to remove. This one, right? Correct. Remove. You can see route has been deleted from the routing table. Then what I need to do here? What will be my next step? What will be my next step? Can I use 1.1.1.1 as the next step? I'm asking the question again. Can I use 1.1.1.1 as the source? Next stop. I can use or I cannot use. Why? Loopback is directly connected, right? Loopback doesn't have physical. Loopback doesn't have. So you can use only a physical interface. Who says that? My question is, can I use 1.1.1.1 as the next stop or not? Yes or no? Why? The next stop thing is from physical interface. The loopback doesn't. Who says? Exit interface. Okay, let's say if I can use exit, can I use exit interface as loopback interface or not? No. 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 Shall I try? Agree? Now let's come back to the question. Can I use 1.1.1.1 as the next stop or not? Yes or no? Yes. How many of you say yes? One only. Some people want to raise hand, but they are waiting for other people. Yes. Can I use or not? Quick. Yes or no? Yes or no? No. Why? You don't know why. How can you forget such a simple thing? What do you mean by next hop? Hop means a router. Next means the next router. On a loopback interface, can there be a next router?
No.
So router's IP, self IP, you cannot use it. It will say invalid next hop because it is this own router. Telling something. Now clear? Next hop means next router. On a loopback interface, there is no next router possible. So that's why local IP, you cannot use it as a next hop. But as an exit interface, you can use a loopback interface. So that means this trick is not going to work. Now tell me, how do I keep 1.1.1.1 as a source? Okay, next up as 192.168.12.2, correct? Exit interface as loopback, like this. Idea? I'll tell you.
Sir, while pinging, we can give the source IP as well as 10.1.1.
Correct. You can say do ping 10.1.1.1. Just mention here source 1.1.1.1. See here. Simple stuff, right? Now, next question. Okay, that was the last question. Why this is failing? Huh? So this time next stop is 12.2. And you can see my packets are reaching here. My packets are reaching to R2. The problem is MAC address.
Sir, while giving the source IP, that the source IP should be a local IP, right?
Yes. Now see. Now we will see why it is failing. What it says? Packet routing. Why? Because the packet is R2 doesn't have a route for 1.1. How it will reply? Okay. Clear? So this command you note down. That is enough for the day, I think. Okay, in the ping command itself, you can give a source. See, you can give it source as a IP also, and you can give a source as a interface also. It has to be local. On local router. If you are pinging from R1 and you want to use a source IP as any other IP, so it has to be present on the R1 on. Okay, like R2 can use any of these IPs as a source. Okay, but it has to be present. R2 cannot use 50, it can use 60, 70, those things it cannot use because not present. In BGP also you will understand this thing. Right? And whenever you want to test your configurations, you do that. Let's say I want to test my routing configuration, whether my routing is proper or not. I can use it. Okay.
Sir, in route R2 routing table, there is no route for 1.1.11, right?
Yeah, that's right.
That's why it's dropped. So packet is reaching forward, reaching to R2, but return traffic is not coming. Is that correct?
Correct. Okay, so if I'll go and add a default route on R2, Now you can try. Yeah. I think that is enough for the day. Okay, guys, then this is it for the day. Recursive again, we will start tomorrow, Monday. Okay.
Sir, can I get the drive access?
So I think anybody who is attending today for the first time,